Okay, so in this video, I'm going to show you how to use JUMP to perform a two-sample hypothesis test on the population proportion, actually for the difference of population proportions, P1 minus P2. So I have an example here picked out, and actually we're going to do this example with using summarized statistics rather than raw data. We'll do the example for raw data in a separate video. So I have an example here from our textbook. So it's an example comparing male and female college students that have a credit card balance. So it says, according to National Credit Organization, the percent of college students who do not have a credit card in their name is the same for males as it is for females. Perform a hypothesis test of this claim using an alpha level of 5%. So sample data revealed the following. All right, so the number of males that don't have a credit card, as you can see in their sample, was 24 out of the 48. And the number of females that don't have a credit card is 20 out of 56. Based on the sample data, can we conclude that the percent who do not have a credit card is the same for both male and female college students? All right, so what I've done is I've placed a copy of the template for the difference between proportions in here. And, as you can see, you've seen this template, I'm sure. It's in our templates folder in My Math Lab. A lot of information going on here. Whether you fill out this template or not, really, that's up to you. This template really is, I created all these templates, to help you organize your thoughts. So for now, let's go ahead and start filling it out a little bit, and then we'll see what we come up with in terms of running the test and jump, because really you could just run the test and jump if you'd like. So I'm going to use the template for now, and then we'll go to jump and we'll fill in the relevant information. So right now, the hypotheses, we're comparing males with females here. So my population 1 and 2, I'll say male here and female. And remember, we're trying to test whether there's, the number of males and female college students that don't have credit cards, if that proportion is the same. All right, so we'll test that against that it's different. All right, they give us sample sizes here, right? So the sample size for each group was 48 and 56. And then for the number that said, yeah, I don't actually have a credit card, for the males that was 24, and for the females that is 20. Now remember, this will get us sample percentages for each group. So obviously this one here is P hat 1, that's 24 divided by 48, X divided by N, and that's 50%. And then 20 divided by 56, that's about 0.3571. It's about 36% for the female. All right, so remember how this test works. What we do is we pool these two results together, and this pooling procedure works under ideal conditions, and those conditions have to be that NP and NQ are both greater than 10. And you could check this out for each of these. And actually that works out for each of these, and you could give that a check. So the conditions for the test are being met. So let's go ahead and calculate the pooled sample proportion, which would be 20 plus 24. Over 56 plus 48. And this will give us our sample proportion, but it's a pooled version of it. So I'm getting 0.4231 approximately. and therefore the Q hat, the sample proportion that said, actually, I do have a credit card, that is 0.5770. Actually, 0.5769. All right, so they had it. So these are all the sample statistics that we're calculating to perform the hypothesis test. Now, remember, there's critical z-score for this test. But what I like to do first is I like to draw my picture, label my critical regions. So this is a two-tailed test because of the fact that we're testing against the alternative being not equal to 0. So here's my critical z-scores. And they told me alpha was 5%. So alpha is 0.05. And if you go to your z-score table and grab the two-tailed 5% z-score, those are plus and minus 1.96. So I'll label my picture over here. So remember, this is 95%. And those shaded regions, the critical regions, the areas, remember, are actually alpha divided by 2, which each of those are 0.025. My surface isn't behaving so nice right now, as you can tell. It's jumping around a little bit. I apologize for that. Probably needs to update, and it always does that on me. So let's just label our decision rule. So here's where we'll fail to reject. And remember, there are 2 critical regions, so therefore there are 2 rejection regions. So this is reject the null, reject the null. So the decision rule, we'll reject the null hypothesis if the testing statistic, this thing here, whatever this thing works out to be. Now, jump will work out for that for us. We're not going to have to actually work that. If the testing statistic is either less than negative 1.96 or greater than positive 1.96. All right, so at this point, I would probably go to jump right now. We can crunch this testing statistic if we'd like by hand. First, it would require calculating the pooled standard error. We'd have to do that first using the pooled sample proportion. So we could do that, and I've done that already. I believe it's around 10%. But, I believe Jump's going to hand us that anyway, so I'll be able to show you that in the output. So let's go to Jump and show you where this statistical calculator is. So in Jump, in the add-ins menu, we added these statistical calculators. And one of them says the hypothesis test for 2 proportions. All right, so the first thing it asks you is, Jump wants to know, what do you give me, raw data or statistics? Well, we have the summary statistics. All right, it opens up the menu for this. First thing it asks you, what kind of a test is this, your alternative? Two-tailed, right-tailed, left-tailed. As you can see, the default is two-tailed, which is what ours is. And then it says, choose your variance option. Use pooling or not. Well, we are actually using pooling every time for this scenario. The non-pooled estimate for variances, we use that on a t-test. So for the two-sample p, we're actually using the pooled estimate for variances. All right, the hypothesized difference, P1 minus P2. All right, we set that up already, as you can see. P1 minus P2, the assumed difference is that there is no difference. And we're testing that against there is a difference, right? So we're saying that when you subtract those percentages, you get nothing, assuming there is no difference. All right, so as you can see in Jump, that's set as default to be 0, but you could change it if the question was, asking you to do so. All right, so sample 1 count. So let's go ahead and put that in there. So even though it's x1, all right, we know that's 24. The sample size for n1 is 48. n2 is 20. And the sample size for n2 is 56. All right. So we're all set up there. We have our sample data put in there. Let's check the reveal decision box. And it gives us a lot of information. Now, a couple things it gives us right away that you can see. The sample proportion for sample 1, which is 50%. In other words, p hat 1. We already knew that. Sample proportion for the females, I'm sorry, is 0.3571. Okay, we knew that as well, right? We calculated that. The z-score, 1.47. All right, what is that number? Well, that number actually is the testing statistic. In other words, right here, our testing statistic. That number is negative 1.47. All right, so where does that land? Well, negative 1.47 is like over here somewhere. So what does that mean? Well, as you can see, the testing statistic does not land in the critical region. The decision rule says fail to reject the null hypothesis. All right, so the result of the test. Fail to reject H sub 0. All right, let's see what else JUMP gives us. JUMP told us to fail to reject, okay. JUMP also calculated the standard error for the difference, P2 minus P1, 0.0972. Now that's actually this, 0.0972. In other words, if you take P hat and Q hat, which are here, right, 0.4231 and 0.5769, multiply them, and then multiply that result by 1 over n1 plus 1 over n2, take the square root of that number, you'll get 0.0972. And what's nice is JUMP tells us that, and it's called the standard error of the difference. Works it out for us. Notice also it told us the critical values, plus and minus 1.96, which is really nice as well. You know, it gives us your critical value. You don't even have to go to a table to look those up. One other thing it gives us is the p-value. So remember the p-value for a hypothesis test. We could use that methodology instead of the old-fashioned critical value and testing statistic method. The p-value is 0.1416. So 0.1416, which is greater than alpha of 0.05. And remember, when the p-value is bigger than alpha, you reject the null. Fail to reject the null. So this is the p-value methodology. So remember, when the p-value is bigger than alpha, you fail to reject the null hypothesis. And when the p-value is smaller than alpha, you reject. All right, so now what? Well, you know, we're kind of all set up here. The only thing left to do really is to, draw our final conclusion. So what I like to do is when I get the result of my hypothesis test, which again is passing judgment on the null, I like to put that answer right here. This is fail to reject. That's what we're doing to the null. That means what's going on here? Well, this is getting rejected. All right, so right now, it appears there is not a significant difference between the number of male and female college students that hold a credit card. So based on the given information, the population, there is not a significant difference in the population proportion of male and female college students that have a credit card.